Hi friends, today we are going to understand how the network address translation work, and we are going to start with the static NAT, and then we will see the examples of dynamic NAT and the port address translation as well. So before we begin, let's talk about a little bit about the network address translation. So network address translation is a mechanism which translates IP addresses in the IP header or in the packet. So basically you can translate either the source IP address or the destination IP address when a packet arrives to a net router. The question comes into mind is that which IP address is translated, whether source or destination. So how is that decided? And then where is the decision taken? Like on the net router, do we have a table, some kind of table which maps one IP address to another, which needs to be translated, or is it done on the source or destination? So to answer all these questions, let's start with the basic concept of network address translation. The very basic concept of NAT is to conserve public IP addresses. So they decided to use network address translation so that public IP addresses usage will be reduced within a company, within an organization. For example, if you see these two routers, router 1 and NAT, they can represent a company and organization. And if you have many computers connected to router 1 and to net router, they all can actually use just one IP address, this 200.0.0 or 201.0.0.2, to reach to the destination outside of the local network, that is the public internet. So this saves a lot of IP addresses. This conserves public IP addresses. And second benefit you get is that your source IP address is translated to a public IP address. So your complete company's infrastructure, your IP addressing mechanism or scheme is hidden from outside. So outside networks do not know about these addresses. So that's another benefit of using network address translation. So first benefit is the conservation of IP addresses, and second benefit is hiding your private network. Now in some of the implementations you only get the second benefit, which is hiding the private network. For example, static NAT. In static NAT you map one private IP address to one public IP address. So in that case you do not get the conservation of public IP addresses part. But if you are using dynamic NAT, you actually map a group of private IP addresses to a comparatively smaller group of public IP addresses. So in that case you conserve a little bit public IP addresses. But the best one is the last one, which is port address translation, in which case the single public IP address, which is on the exit interface of the net router, is used to send all the requests coming from any private IP address within your organization. Theoretically, a single public IP address can manage up to 64,000, 65,000 private IP address requests coming from inside, because it uses different port numbers, different client-side port numbers of the same public IP address. But more on that part later. Right now, let's concentrate on the first part, static NAT. So we want to do a static translation, point-to-point translation, and what we are going to do here is we are going to translate this particular part here, which is 10.0.0.1 from router 1, and when the packet goes to net router, we want to translate 10.0.0.1 to 201.0.0.2. So when the packet goes from router 1 to router 2, it appears that it is coming from 201.0.0.2, which is actually the net router. So right now if I go to router 1 and for example telnet to router 2, you will see that the telnet packet will actually show it is coming from 10.0.0.1. So let me show you that. So I go to router 1 and I telnet to router 2, ask the password, provide the password, and I'm inside the router 2 now. So if I check show users, it will tell me who is connected to router 2 using telnet. And this is the virtual terminal telnet, and it says it is 10.0.0.1. So the translation is not happening and our private IP address is revealed outside. So two things: first of all, our private network is revealed. Second thing, it won't actually work in this way in public networks, because any private address will be filtered by the ISPs. So it's not even going to be working like this. So let's do the translation. Now let's translate this private IP address when it goes out to the 201.0.0.2, and when it is coming back, we will translate the IP address back to 10.0.0.1. So we will create a static entry on net router So we will go to the network address translation router, and first thing you need to do is to designate the interfaces as inside and outside. So as you can see in this diagram, fast Ethernet 0/0 on net router is inside port, and fast Ethernet 0/1 is the outside port. So let's designate them accordingly. So interface fast Ethernet 0/0 is inside, and fast Ethernet 0/1 is IPNet outside. So that's the designation part, 00 and 01, as you can see. And second part is the mapping of 10.0.0.1, which is the router 1's IP address, to 201.0.0.2 of the net router. So for that static mapping, I will use the command IPNet inside source is static, and I want to map 10.0.0.1 to 201.0.0.2. Once this mapping is created, now what's happening is that this mapping is inside mapping. You can also create outside mapping, IPNet outside, but that has a different application, and I'll tell you what happens when you do the inside mapping or outside mapping in the second part of this tutorial. But right now let's just do the basic inside private IP address mapped to the outside public IP address. So now if I go ahead and go to router 1 and telnet again, so I'll get the connection is closed, so I'll do the connection again, telnet 2.2.2.2. I'm through, provide the password. I'm inside router 2. Let's see who is connected to me, show users, and right now as you can see it is actually showing the old entry as well, but you can ignore that part. It's no longer connected, it will be removed, but this is the current entry, currently connected telnet connection, and yes, it is coming from 201.0.0.2. so our telnet connection has been translated. If I go to network address translation and I check show IP net translations, it will show me that the 10.0.0.1 is translated to 200.0.0.2, which is inside address. Like, so inside local means my private IP address inside is translated to a global IP address inside global. Now inside means it is on the inside domain. As you can see in this diagram, it is the inside interface or inside IP address translated to an inside IP address of 201.0.0.2. And outside we did not translate, that means the destination IP address is not translated, it is still the same, which is loopback address there. So that's translation is done. Now how it is actually working is, if you see the overall translation round trip, you will see that initially when the packet goes to the net router, it goes from 10.0.0.1 and it wants to go to router 2, which is 201.0.0.1. as you can see, 201.0.0.1, or even the loopback, it can be destination, any destination which is reachable. So when it reaches to net router, you can see that the source IP address, which is shown in the red, is translated to 201.0.0.2, and the destination remains same because we still want to go to router 2, so destination is not changed. When router 2 receives this, it replies back, the source becomes router 2 and destination becomes the one who requested the traffic, 201.0.0.2. So when this goes to net router translates the destination now this time back to 10.0.0.1, and the packet goes to our router 1. And for router 1, as you can see, it is completely transparent. It looks like it was sent from 10.0.0.1, it is received on 10.0.0.1. Excuse me. And on the other hand, for router 2 also it is transparent. For router 2 it looks like it is coming from a public IP address 201.0.0.2, so it is replying back to 201.0.0.2. So that's the very basic net translation, and it helps your company to translate the source IP addresses into private source IP addresses into public IP addresses. But this is not a very efficient method if you have many IP addresses to be translated. So the more efficient method will be to use dynamic net, and the best method would be actually to use port address translation. So in the next video, I will explain you how to configure dynamic net and the port address translation. And in the last video of this net series, I will explain you what happens when you configure the inside mapping and outside mapping. Like right now, if I go to net router, I have configured IPNet inside. So what happens if I configure IPNet outside, and how does it correlate to the source and destination translation? So thank you very much for your time.